Hey class, welcome to another episode of Bran Academy. As always, my name is Bran. I'm Mr. Wynn's twin brother. And today, he's having me teach you guys about Chapter 13-5, Probabilities of Independent and Dependent Events. Okay, so let's dive into it. The math itself isn't hard, but the vocabulary and understanding the questions, that's the big part about this chapter in general, okay? So independent and dependent events. A compound event or composite event, okay, compound, composite, that just means more than one, consists of two or more simple events. For example, okay, here are your two events. Drawing a queen from a standard deck of cards, then drawing a king. Real quick, some of you guys might be wondering what is a standard deck of cards? Is this, for those of you guys who like to gamble, I don't recommend it, but it is pretty fun. Anywho, okay, so basically there's four of every card, right? 4 aces, 4 twos, all the way to 4 jacks, 4 queens, 4 kings, okay? There are 52 cards total, okay? 52 cards total. Okay, there are 13 different ones, 13, and then 4 of each kind, okay? And I know some of you guys don't know the lingo for it yet. This is what we call a spade. That's a spade. That's a heart. That's a diamond. That's a club. Okay, clubs. Okay, so drawing a queen from a standard deck of cards. Okay, so there's going to be two types of situations we talk about. One situation is called with replacement. That means every time you draw a card, you are going to replace it back. Okay, so for instance, the probability of me drawing a queen is 4 out of 52, right? There's 4 queens. Okay, so let's say I draw a queen, right? And then I'm drawing another card. So it's my second card here. The probability of drawing a king. So with replacement, right? That means whatever card I picked first, I put it back. Right? I put the card back. So then I still have how many cards in the deck? I still have 52. So the probability of me getting a king, I should probably color code this, is still 4 out of 52. Okay. So let's say the first one in blue here. So probability of getting a queen, and then probability of getting a king on the next draw. Okay. The next situation is what we call without replacement. Okay, so the first card I draw, or the chances of me drawing a queen for my first draw is still 4 out of 52, right? Okay, 4 queens out of 52. But once I make that attempt, right, I took that card out. How many cards do I have left? 51. Okay, 51. And technically speaking, there are 4 kings. Okay, so that's without replacement. Okay, so the probability is slightly different. Okay, without replacing the card. Okay, you have just 1 card less every time you draw one. All right, probabilities of multiple events are called compound probabilities. Okay, compound events can be independent or dependent. So let's talk about this here. Events A and B are independent. Independent events, if the probability of A occurs, does not affect, okay, underline box that, does not affect the probability that B occurs. So basically, of these two here, guys, of these two situations, right, an example of an independent event is with replacement, right? So the probability, P for probability, drawing a queen, then a king with replacement, right? So you're replacing the card back. So this here, these are two independent events. If you draw the queen, it will not affect the draw of the king because you're replacing the card every time. Next one, events A and B are dependent events. Okay, dependent as in it depends, right? It depends on what happened before. So A occurs in some way that changes the probability of the B event. So in this case, the same idea, probability of drawing a queen, then a king, without replacements, okay? So if you don't replace it, then it's gonna affect the next card, right? So again, event A is drawing a queen, event B is drawing a king. And if you do it without replacement, that's what we call a dependent event. Okay, it depends, right? It depends on what happened beforehand. All right, let's kind of do some examples here. Okay, all we have to do is determine whether it's independent or dependent. Okay, so we can kind of skip this here. I mean, this is a marble example, not a big deal. Determine if the events are independent or dependent. So tossing a coin 4 times, and you get tails every time. Okay, so you toss a coin, tails, 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 tails. What are the chances of me tossing a coin the 5th time and getting heads, right? So all because I got tails 4 times in a row, does that really affect the 5th time that I flip it? The answer is no, right? So this here is independent. Okay, it's independent because that 5th toss, right, the probability of that does not change, okay? This is what we call a gambler's fallacy, almost, right? If you're trying to bet on the coin toss, right, it was tails 4 times in a row, it has to be heads sooner or later. That's what we call a gambler's fallacy, okay? Because in the end, these are independent events. So it's still 50-50 no matter how many times tails popped up in the past. The amount you pay attention in your class and your overall grade, some of you guys might think it's independent, but I'm going to say it's a dependent event, okay? The more you pay attention, the higher chance you do better, right? Not saying you will do great if you pay attention, but you just have a higher chance of doing great, okay? So as dependent, drawing a queen from a deck of cards after drawing 2 cards and not replacing them, okay? So you don't replace it, right? So if you don't replace it, right, you take out the card every single time, thus affecting the probability. So this is a dependent event, okay? Here's some notations for you guys here. If 2 events, A and B, are independent, then the probability of event A and event B, the formula for this, you just simply multiply it, right? So the probability of A times the probability of B, okay, which we'll talk about that in a bit. Obviously, an example that we just talked about is literally up here. So what you could do, you can just leave it blank if you want, or you can just copy and paste it, which is what I'm going to do here. Here's an example, right? Something with replacement, right? You simply just multiply those 2 probabilities, right? The probability of getting a queen, this is the queen, the probability of getting a king, right? Individually, right? They're independent. If they depend on each other, right? Here's your formula. This is the probability of A, so the first thing that you do, times the probability of B happening, given, so that line there means given that A just happened. Okay, so this little line here means B given A. Okay. An example, basically from the top here, is with, whoa. Oh, shoot, guys. Look up here. This should be 3 out of, oh, no, yeah, that's right. Shut up, Mr. Win. Okay, so copy. So if you notice, the probability of getting a queen, let's say, so A is queen, right? If I wanted to, I could have done this, like probability of getting a queen. That's how you would write it. Probability of getting a queen, right, would be 4 out of 52. Now the probability of getting a king by itself, right, it would be 4 out of 52. But probability of getting a king, given that A just happened, aka you don't replace the card, then it's 4 out of 51. Okay? So this is the probability of B, given that A just happened. Okay? All right. Let's go to the back side. I shall probably pause the video here. We'll do the examples on the other video, okay? I'll just shorten these 2.